All right, moving on to number 3 in 2.1 of rational expressions, we're going to simplify or reduce the following rational expressions to lowest terms. And before we get started, I wanted to just kind of review the idea of what it means to simplify a fraction. Um, to simplify a fraction, we want to take out any common factors that are in both the numerator and the denominator. So some of you might already be thinking this is 2/3, which is the correct answer. But if I asked you, how did you get to that result? You might say I divided it, both the numerator and denominator by 7, which that works, okay. So someone might also say I canceled out a 7, which is confusing to some people because there's not even a 7 that's present. But if you look at this and you would write this out in factored form, this is 2 times 7, and this is 3 times 7, okay? And so what can happen here is we know that 7 divided by 7, okay, 7 divided by 7 equals 1, so we can cancel that out, all right? So we divided out a 7 or canceled out a 7. So this process right here is what we need to remember when we're working with rational expressions, that we're going to need to factor things and able to cancel them, all right? So this idea doesn't work, all right? If you take a look at this, if you had 7 plus 10 over 7 plus 5, okay? You cannot, now hopefully you know the answer to this is 17 over 12, and then you would change it to a mixed number or reduce it if possible. But you can't cancel these 7s out because they are terms, okay? So, you know, we'll look at that too a little bit more and just try to resist the temptation if they're tied up with a addition that you can't cancel them, okay? And we'll review that as we look at a few more, all right? So if you take a look at this first one, letter A, all of these things here are tied together with multiplication. So what I can do is I can first reduce this front number part here, this 4/10, and that's going to reduce to 5 over 2, okay? And then I can work on the x to the 5th over x to the 4th. Now, this we've already done in a previous chapter. We know all these x's would cancel out and leave me 1x on the top. And then I can work on my y squared over y to the 3rd. Again, all these would cancel out and it'd leave me 1y on the bottom. So that is the simplified rational expression. Okay. Now looking at B, we get to the idea that I was reviewing with you on the other paper, is that these are not ready to be canceled yet. I have to factor both the numerator and the denominator. Okay, so I'm going to factor it right next to it here. I'm going to say, okay, on the top I can pull out a 2. So if I pull out a 2, I have 2x plus 4 and x plus 4 on the bottom. Okay, now hopefully you can spot, even though the denominator isn't in a parenthesis, that this piece matches this piece. Okay, so I can cancel this piece with this piece. I cancel out the whole binomial. I'm not canceling individual parts, and what I get here is 2. All right, so factor, then cancel, factor, then cancel. All right, so looking at C here, it's a little bit confusing, but you'll get the hang of one like this. And let me show you. We're going to factor out a 2. And so I got x minus 2 over 2 minus x. Now these are not an exact match. Okay, I'm going to make a note of that right here. Not an exact match. Okay. And I'm going to show you the math one time on this, or maybe a couple times, that what I'm going to do here is I'm going to change the order of this denominator, okay, so I'll write it over here. I got my numerator. I'm going to change the order of the denominator. Now look, the 2 is a positive and the x is a negative, so I'm going to write negative x plus 2. Okay. Now what I learned in the previous chapter was that if the leading coefficient is negative, okay, right here, I can pull that negative out front. Now I know it's already out front, but I want to pull it out in front of a parenthesis. So I have 2x minus 2. I'm going to pull the negative out, and I have x minus 2, okay, because I pulled that negative, that's going to change signs here. Now you should be able to see I have exact match here, okay, so that can cancel out. So you see what happened is with this piece right here, with that piece right there, it does cancel out, but it produces this negative. It produces a -1. Okay, and we'll use that in the next example. But let's finish up this one. So I have 2 over -1, which is -2. Okay, or you could just move that negative up to the numerator there. All right. So looking at D here, once you learn how to spot these, that hey, this almost matches this. They're almost identical. The thing is that they're just flip-flopped around subtraction. I could go through this exact same logic that I did over here, and these are going to cancel out. These are going to cancel out, but when they cancel out, they produce a -1. So I have to remember that they produce a -1. So somewhere I have to like put in a -1, and the answer then is -1. Okay. If you look at just one more example in this video, is that if we had this exact same problem, but we had a plus sign in the middle, you might remember there's a thing called the commutative property of addition, and it's okay to flip-flop around addition. So if I get this in the same order as this, I get 3x squared plus 3 over 3x squared plus 3. That's equal to 1. Okay, so hopefully you see the difference between a flip-flop around subtraction versus around addition. Okay, so that's a useful little tool as we do some of these problems. All right. Okay, we'll look at a few more of these.